Hey there, I'm Zach from Pinecone, and today we're going to learn how to use Jupyter Notebooks to do machine learning and/or AI tasks, and we're going to learn how to run them for free using Google Colab. Let's jump in. You can go to github.com, pinecone.io/examples. The example notebooks that we're going to look at today are published by Pinecone. Pinecone makes a extremely performant cloud-native vector database that provides long-term memory for AI. However, all of the different tips and tricks I'm going to talk through there, as well as a security heads up to use notebooks safely, will be applicable more broadly to any kind of Jupyter notebook and to any other environment where you might want to run them. A Jupyter notebook is a file format that allows you to combine both Markdown and text and also Python code and then execute that Python code. So it becomes a convenient way to build out even advanced use cases, and then anybody can read them, edit them, run them quickly. So that's what we're going to be taking a look at today. So if you come to github.com, pinecone-io examples, you'll find our examples repository. If you step into the learn subdirectory, you'll find our README, and the README really walks you through everything that you need in order to run these notebooks, including some common pitfalls when you're first starting out with Google Colab. So I just want to point this out in case you happen to be the type of person that would prefer to just follow along via text and the screenshots. You can go through this guide and get up and running with any of the notebooks here and start playing around for free and learning various artificial intelligence / machine learning tasks. That is there, and that is a resource that you can use. So one of the first things to understand when working with Jupyter Notebooks is that Jupyter Notebook is a file that ends in the file extension .ipynb for interactive Python notebook, if I had to guess. What's cool is that if you view a Jupyter Notebook on GitHub, there's a special preview experience that gets rendered. So this is the rendered version of the notebook that you would normally see if you're working in something like Google Colab, which we'll look at in a moment, or Kaggle, or other data science platforms. But you can also switch to the code itself. And then if you look at the code itself, you'll notice that it's JSON, and that the JSON essentially describes the various fields, their inputs and their outputs, like cell type, markdown, right? So as we talked about just a moment ago, Jupyter Notebooks are comprised of cells. This is a cell. And cells could be text or markdown. This is also a cell right here. This is a cell. This is a cell. And so together, they provide this comprehensive experience where you can mix text and code, and the code is runnable. And so this is important because this is a really efficient way to do data science type tasks, AI tasks. It's a really efficient, quick way to test something out that you're not sure if it's going to work or if it's the ideal path, and put it in a Jupyter notebook and quickly send the link over to your colleagues and say, hey, how does this look? Is there something we could do to improve it? And then also, as we'll talk about a little bit later, there are some security considerations to be aware of, because here we are viewing a notebook that has been open sourced already on GitHub. But importantly, you'll notice that the cell's output, so the output of the code that is contained in the cell that's generated when the code is run, is itself also stored in that ipynb file extension, and then therefore renders and shows up in GitHub, right? So as we'll talk about a little bit later in this video, you need to be aware of that if you're going to be printing any secrets to the screen, for example. But at a high level, the reason why notebooks are so popular and really pretty wonderful to work with is because you can so easily intermingle text and explanation and kind of tell a story alongside of code that you can execute and run. Because the cells, tend to be bite-sized, they don't have to be. You can put as much code as you want in them. But because they tend to be bite-sized, in my experience, it also ends up being, once you figure the notebook out and get everything working correctly, they're relatively stable. So you can run it all the way through, as we'll talk about in a second, in Google Colab, or we can run it cell by cell, and you can pretty much expect it to work. I mean, things always are going to change under the hood. It's possible that some dependencies have been updated, or you're running a version of something that's super out of date and you come back to it 2 years later and maybe that's not going to work perfectly. But in general, the point is once you kind of codify your workflow in a notebook, it's a really nice format for sharing, coming back to later and running yourself. So overall, myself being more of an application and infrastructure developer, and then coming more recently to use notebooks, found it to be a pretty pleasant experience overall. In this example, partly because of the text that helps us understand, this notebook is going to demonstrate how Pinecone similarity search as a service helps you build a question answering application. And to demonstrate that, we have a data set of questions, and we're going to convert all of the questions into embeddings or vectors using a language model, and then upsert those vectors into Pinecone database, and then perform a semantic search on it to see which questions are the most similar. But the cool thing is that as I mention that and talk about it, you can literally see the code where we do each step. And so that's also just what makes notebooks an ideal format for tutorials, explanations, quick demos, proofs of concept. If you're doing a data heavy app that has a requirement where the data model needs to be perfect and the results that are coming back are critical to the success of the app and user satisfaction, I find that oftentimes it can be helpful to do that work in a Python notebook first or separately, and then use that notebook kind of as a sanity check or a workbench, if you will, to tweak and tune the model and your data set until you have it exactly the way you want. And then only then, go and worry about actually writing the application code that's going to hook into that database. So overall, Python notebooks, very useful. So let's look at actually running them. For the notebooks that you're going to find in the Pinecone examples repository, as well as for notebooks that you'll find elsewhere around the internet, you may find these badges, as they're called, these buttons that help you open them in whatever service. So in our case, you're going to find a lot of badges that say open in Colab. And indeed, if you click that, you will get your Python notebook opened in Google Colab. Or Jupyter Notebooks encode both text, right? So for humans to read, and then actual code for machines to execute. So that's the file format of a Python notebook. But because there's code to execute, we actually need some kind of compute platform or hosting provider to where we can run the code. So what we're doing by opening this notebook in Google Colab is doing just that. Google Colab is a service that allows you to run notebooks, and meaningfully you can use it for free. So it's an excellent way to get started and start playing around. And then later on down the road, if you're doing something that's incredibly GPU intensive, for example, such as training a large model, then you can also conditionally upgrade and ask for more, compute and GPU power to kind of get your task over the line. But the very cool thing is that out of the gate, Google Colab is free for everyone to use. So as mentioned in our getting started guide, even though I just popped this open and it worked fine for me, part of the reason that is the case, why that worked just fine for me, is because I've already gone through a couple of these little gotchas here that I mentioned. So in one case, don't be alarmed if the first time you try and load a notebook of your own in Google Colab, you start to get errors because, for example, one of the things you need to do first before all this will work properly is to authorize Google Colab to open GitHub links on your behalf. There are other ways that you could run notebooks. You could import them from local files, etc. But it tends to be pretty convenient to be able to just click the link and run it in Google Colab, especially if you're trying to just quickly wrap your head around the way something works. You might also run into this error that says Colab essentially couldn't open a new browser window on your behalf. That could be because of your browser security settings where you've disabled pop-ups for the Google Colab domain itself specifically, and or you're running a browser that will block pop-ups by default, which is in general, makes sense and a good thing to do. So keep an eye out if you run into this error for a little pop-up widget in your browser that is asking you for permission to open Google Colab pop-up windows, which you should grant. So once you've gotten through those things, then when you click the button for open in Colab, you'll get essentially the same experience that I got here, which is the notebook loaded in Google Colab and ready to roll. And so we talked about, cells before. This is a text cell. And what that means is that I can edit it. So then I can also, save a copy in Drive. I could save a copy in GitHub Gist, save a copy in GitHub as its own notebook. I could just save this to my Google account via Colab. I could also download it, and then you can download it in two different file formats, both the .ipynb that we were talking about, and then also .py as just a Python file, which you can also execute, which is pretty cool. So that's a text cell. It's meant for, kind of providing context and explaining what the overall notebook's going to do. This is a code cell, and we'll talk about a couple of things here. So for code cells, there's a button that says run cell, or the hotkey is Control Enter if you're a keyboard person. You're going to get a warning in most cases, and this is saying that this notebook's coming from a third party. It wasn't written by Google Colab, so it's just asking you for your permission to run it. I may be biased. I'm going to say that running any of the notebooks under the Pinecone examples repository is safe to do. And what this cell is doing now that we're running it, and which you can see through this animation here, is it's going to execute the commands that are defined in this notebook cell, in this code cell. What's important to note too is that unlike this second cell here, this second cell is just pure Python code, right? It's saying import pandas as PD as an alias that you can use, import numpy as NP an alias. This first cell it has these exclamation points in front of the pip install commands. So why does it have that, and what are those doing? What that's essentially, those exclamation points are essentially saying, don't run this through Python. This is effectively a Unix command. So just as you would in your terminal or in your shell, if you were going to pip install some dependencies, or pip install, -r requirements.txt is a very common way of doing it, then you would not be writing pip install inside of a Python file. You would be executing pip install as a shell command. And so essentially that's what this exclamation point is saying, is run these commands as shell commands so that we can actually pip install the requirements that we're going to need below here. Similar to the concept of scope in programming languages like Python and JavaScript and many others, what happens, or what is run initially at the top of the notebook, remains in scope for subsequent cells. So what does that mean, and why is it important? Let's say that we're trying to do this line, Pinecone create index. We're going to create a new index for upserting vectors, and then we're passing in an index name. Well, in this cell alone, which is a one-liner, right? It's just a one-line cell of code. The index name is not defined. So if I were to go and try and run this right now, I'm going to get an error about, first I'll get an error about, you didn't initialize Pinecone, but Pinecone itself is not imported or defined. But if I were to do that, I would also get an error about index name is not defined, right? Because index name is actually up here. So that's just to say that the order in which these cells are executed does matter. And so maybe that's a good time to talk about how in this runtime window or menu item, you have the option of doing a couple of things. You can run all the cells at once, and that will start from the top of the stack and go all the way down through every cell running it, which is the way that most Jupyter Notebooks tend to be authored, with the expectation that you can run cell 1, then cell 2, then cell 3, then cell 4, and then anything in cell 4 and beyond is going to reference variables or API clients that were created in cells 3 through 1 previously. So this can be the run all command, which also has its own hotkey here, can be a really convenient way to essentially, I just want to load this notebook. Maybe you have a notebook that tests a service at your company, or a model, or a side project that you have. I just want to load this notebook and run it end to end because I made some changes to something else, and I want to make sure I didn't break the API client, for example. Run all is great for that. If you're just trying to learn, or you want to understand something better, then it can be great to do what we're doing here, which is to step through each cell individually and run them cell by cell. So the first cell we ran just now, it installed the Pinecone client, matplotlib, IPy widgets, sentence transformers with a special param that was passed. So these are pip installing requirements that the Python code in subsequent cells is going to require. Then we ran an import. You'll notice here this check mark. It's kind of faint and small, but if you hover over it, it's going to say the check mark indicates that the cell was executed correctly or successfully. So it was executed since last change, executed at what time it was, and it took 0 seconds because it was milliseconds in order to just do these imports. Okay, so next we would run this cell, which is going to ask for your Pinecone API key or your API key. And then, conventionally you would enter in the value here. And then also the other value that you need to initialize the Pinecone API client is your environment, which you can get from the Pinecone dashboard, which we'll look at in a second. Over here in our getting started guide, this is a good time to talk about. There's all kinds of patterns that you're going to come across in various notebooks about how to set secrets, and an API key almost uniformly across the internet, an API key for any service is a secret. And what that means is if it uniquely identifies your account usually, and importantly, it is tied to your billing payment source, right? And so that is one of the primary reasons why you don't want to go and create a whole bunch of API keys for some fancy new service, attach your credit card to it, and then share those API keys with everybody on the internet so that they can use them to spin up compute resources or make expensive API calls on your behalf. Your API key is instead a secret. It's something that you want to keep to yourself, secure within your dev team perhaps, or just your own personal key, or perhaps within your organization if you have a way to share it. So we highly recommend using password managers. You can even see in my browser here, I've got Bitwarden, which I use for certain things, 1Password, which I use for other things. Bitwarden's a great free open source version. 1Password is also great. So these are good places to keep API keys if you don't have anywhere else to put them. I will recommend against just hard coding them into your shell environment. But when you're working with a notebook like this, I want to show you how you can actually go a little bit deeper on the security angle. And essentially what we're going to do here is prompt ourselves using this password field for an API key. And then what this code is going to do is load the Pinecone API key into an environment variable of the name Pinecone _ API _ key, and using getPass. And getPass is a utility that actually provides this prompt. And as we'll see, let's actually do this now, and we'll just make a new cell. And then if I drag this cell upward, or press the up button to go like that, and then paste in the code like this and execute it, you see I get this little prompt here. And now if I were to go to my Pinecone dashboard, which is https app.pinecone.io, and log in, then I can go here and get my API key. You can click show key value if you want to see it yourself. You can also click copy key value. And importantly, just like I'm doing right now in the video, I've copied the key value. It's still secure because nobody can see it. I paste it here, and it's treated as a password field. And so now I can press enter. And what that means is that Pinecone _ API key, the environment variable, now contains my key. And I can continue working through this notebook without accidentally forgetting that I've hard-coded the value of my API key. So recommend using this pattern wherever possible. There is a copyable code snippet under our examples learn README, which contains the getting started guide here for how to work with notebooks in Google Colab. If you wanted to add a new text cell, I can do that too. I think Markdown is supported out of the box, right? So I get an H1 there, and I can do this H2. Those are the basics of working with cells in Jupyter Notebooks. Now that we've securely loaded our API key in this step here, Let's actually go through and continue executing this notebook. The other thing that we'll need here is our environment, and the environment, the Pinecone environment is not strictly itself a secret, so it's okay to hard code it like this. So this cell, again, super quick to return. It's just setting a new variable called index name, and then we're going to use, as you can see in subsequent cells, that index name. So if I just continue stepping through these cells and executing them, that one took 1 second. What this is doing is actually making an API call to Pinecone and saying, list all of my existing indexes. If you find that index, question answering that already exists, delete it, because we're about to use it here for this demonstration. And so now we can actually call Pinecone create with the index name and the dimensions. And then we're ready to connect to the index. So what this does is instantiate essentially a REST interface to the Pinecone index so that we can form upserts and queries, etc. with it. So here you can see another nice use of the text-based cell where you can link off to additional context if you need and explain that, hey, this is the actual data set that we're using. Here's some question answering pairs. And so for example, this particular competition or data set that Kaggle had run in the past 6 years ago, looks like, was for Quora question answer pairs. Can you identify question pairs that have the same intent? So even if the questions are phrased differently, even if they have different keywords in them, can you actually get at the root semantic meaning and understanding of the questions to identify duplicates? And that's what this particular notebook that we're stepping through as an example is going to do. So as you can see, if we read the code in this cell, we're importing the request library. We're setting the data directory where we're going to write the file that we download to a temp directory. And so we've got a temp directory here, and then a full URL from where we're going to actually download that set of questions. And then we define a function called download data, and then we call that download data function in this cell. And then we can just continue executing cells individually if you want. And again, I recommend doing it that way, especially in the beginning if you're trying to learn how a new technique works or to understand a particular notebook. So in this step, we're actually going to create vector embeddings. So embeddings are numerical representations of the actual semantic meaning of whatever data you hand it. So in this case, it's going to be the numerical representations of the semantic meaning of the questions that we downloaded from the data set. In this step, we are performing the upsert into the Pinecone vector database. So the vectors that we've just created from the embeddings model, we are now upserting it in chunks into Pinecone vector DB, and that will enable us to perform semantic similarity search in the subsequent step. And that will in turn help us identify which of these question pairs that we've seen are semantically asking the same thing, even if they're not phrased identically, even if they don't use the same keywords. Right? So at the semantic level, what is the actual question that's being asked and where are the duplicates? So here we've got another text cell, and this text cell is explaining that once all of the vectors have been upserted, this is how you actually query. So first we're going to have some query questions that we define in a list. So what is the best way to make money online? How can I build an e-commerce website? These are the two initial query questions. Note importantly that to perform semantic search against a Pinecone database, we're going to use the same embedding model to encode the query questions to vectors as well. And this is what allows, Pinecone to return extremely relevant results that are closest to, in vector space, the same queries that we're sending in. And so that's what this cell is doing. So convert the query questions themselves into vectors, actually query the index here, passing the parameter top k of 5, which means when you're performing a nearest neighbor search, give me back the top 5 closest matches according to what was queried. And then we're going to loop through the question and the result in query questions and query results. I'm going to create these IDs, scores, and a data frame result, essentially, and then we print the data frame result. And so as you can see from the last time that this notebook was run, the original question, what is the best way to make money online? The most similar questions based on semantic similarity search are, what is the best way to make money online? Score of 1, that makes sense. What's the best way to make money online? What is the best way for making money online? What are the best ways to make money online? What is the best way to make money on the internet? So despite using various phrasing and different keywords, we can understand at a semantic level that all of these questions are essentially the same question. And then finally, in this notebook, as is recommended if you're just using this for testing purposes or learning purposes, at the end you can delete the index to save space. If you are new to Pinecone, Pinecone actually has a generous free tier plan that allows you to use a vector database and create the index, an index that you want for free, and populate it, use it in notebooks just like this one, but you can have one at a time. And so you might want to clean up the index as long as you don't need it anymore. So in a lot of our example notebooks, this will be the final cell that you'll notice. It'll delete the index once you're done with it. And that's essentially how you might step through a example Jupyter Notebook end to end. So now let's talk through a couple of other items here. So one thing to note, as mentioned before, that's how you can, interactively step through, kind of understand, and maybe even modify text or code if you want. Perhaps you want to print some variable out to understand what a data structure looks like in more detail. And, stepping through each individual cell is an excellent way to do that. However, you can also use notebooks for testing purposes, and notebooks can also serve as a great way to sanity check that everything's working properly. You can hit run all, and then if there's API keys are required, as we talked about earlier on, you can provide those securely, and then the notebook will run all the way through, executing each cell in sequence and erroring out if it hits a problem and stopping execution, but otherwise getting all the way to the end. And essentially, you can use these as sort of semi-manual, semi-automated, if you will, testing, sanity check or smoke tests that something is still working properly. And so that's why you might want to run all on a notebook. Other things that are useful is to show, hide code, show, hide output. In edit, there is a handy function that, let's say that you've been tweaking and testing and modifying this notebook, and maybe you're building a notebook for a different purpose. And you've done a bunch of test runs, so there's a lot of output data such as this. This is the output from pip as we installed our dependencies earlier. And now you want to start afresh and do a run from top to bottom. You can clear all outputs, and that will get you back to a nice clean state where it's just the defined cells, essentially. You'll still get the check marks here if they were run recently within the session where you're still attached, where this notebook is actually attached and ready to run. But that can be a handy way to kind of clean things up and then do another test end to end. Other things to note, when you're done with a notebook, or if you want to share it with your team, you can hit this share link. So there's a couple different ways to share. You can provide someone a notebook link directly. If you do that, that will go through Google's auth system. And so in many cases, depending on if you use Google Workspaces or not, you may see in your email later a request from whoever you sent it to, your colleague or friend, asking for access to that notebook that you might need to grant. You also have the option of saving a copy as a GitHub gist, saving a copy in GitHub, saving just to your actual Google account within Colab, and then downloading, which is interesting because you can run Jupyter Notebooks locally. You can download the IPy and MB output or file extension. You can also download as a Python script. So downloading as a Python script is useful if you were to say, okay, this notebook describes pretty much the functionality I'm trying to achieve, but I'm ready to import this functionality into my existing Python program, or I have an environment where I'm already running Python and I want to turn this into a Python script, or I just want this Python script to run locally so I can make some modifications to it more easily in my IDE or code editor, if that may be the case. You can also download a Jupyter Notebook as a Python file, and you'll get, when you download it, a combination of the text cells and the executable Python. So you likely need to do a little bit of cleanup and rearrangement, but that can be very useful time saver as well. So be aware of that. The one thing I will mention in terms of security that's really critical to understand is in this notebook, for example, there's one secret, right? It was the Pinecone API key that we discussed earlier. And we talked about why API keys are secret almost always and why you want to treat them very carefully and make sure that you're not leaking them on the internet. And so that's why it's so critical to understand that depending on the modality of how you share your Jupyter notebook, it's possible for your API key to be in the output of one of your cells. So if you are, for example, if you were trying to get your API key working, or you're trying to get this init call working and for some reason it wasn't, and so you say very reasonably, I want to print out what is being passed in as my Pinecone API key, just be aware if you go and if you do a print statement here like this, right, and do like the os get n Pinecone API key like this, if you were to save this and or share this with somebody and or publish it to GitHub, depending on if you run it already or not, that's one way that you might end up with your actual API key in the JSON output or in the notebook output, and then viewable by people other than yourself and other than your teammates on GitHub or wherever you were to share this. So that is a potential risk that can happen with any API key, not just a Pinecone API key. In a lot of notebooks, both our examples and others, you'll find that there are sometimes more than one API key involved. You might have a Pinecone API key for your vector database. You might also have an OpenAI API key to do embeddings, to call ChatGPT-4, for example, for completions. Just to be aware that that is a potential risk vector for leaking your API keys if you're using the notebook alone on your own and you just save it and share it, and you're careful to only store the API keys as environment variables and not print them out and not save or share or publish the notebook, you're fine. But in general, be aware of that, because the risk comes in when you are ready to share your notebook. It is definitely worth your time to double and triple check that you haven't logged an API key somewhere in your output, in the output of one of your cells, so that it's easily findable. And B, highly recommend using a security or secret scanning solution such as GitGuardian or even GitHub's native secret scanning that you can set up on your repositories. So there's a lot of good options for helping you automatically, programmatically detect that an API key or another secret, such as a database credential or username or password combination, has been leaked online or on GitHub. So highly recommend looking into some of those options as well. That's about it for the intro to how to use Jupyter Notebooks for machine learning and for AI. I hope you found this useful. Be sure to check out all of our many examples here. So under the Pinecone examples repo, under the Learn section, we've got the example Jupyter Notebooks split out roughly by the topic that they cover. So here's how you would build recommendation engines of all kinds, article recommenders, audio, movie, product recommenders. There's some cool experimental stuff. There's generation examples, search, security. So generation example, there's chatbots, Hugging Face, agents. We've got AWS SageMaker examples, LangChain, Llama Index, OpenAI, LLM field guides. Lots and lots of really cool stuff in here. So highly recommend checking out github.com Pinecone.io examples for all of your AI and machine learning free Jupyter Notebook needs. And as always, if you encounter any issues or have feedback or want to make contributions, we welcome that. It's all open source for a reason, so please feel free to file an issue or ask a question or contribute pull requests if there's things that you'd like to see, or if there's little tweaks or fixes that you find as you come across the stuff. All right, and with that, I'll say thanks for watching. Have a great day.